Hey everyone, in this video I have 4 triangles I want us to take a look at, but we're not actually going to solve any of these triangles. We're not going to find any of the missing side lengths or angles. We're just going to talk about determining which of our laws we should use. Should we use the law of sines or the law of cosines to get us started in solving these triangles? And so I just kind of came up with 4 random triangles. They're not drawn to scale, and so you should never kind of use the shape that's given to make any of these determinations. It should all come down to the numbers that are provided. So depending on the given information, we have to use that to determine which of our formulas is going to be usable to find some of the remaining pieces of information. One thing to remember is that when we're actually applying the law of sines to find a missing piece of information for one of our triangles, we're really only using 2 sides of this equation at a time. Only 2 sides of the 3-sided equation that we write the law of sines as are used, and so we can see that there are 4 pieces of information required to plug in into this equation. We need to know angle A, angle B, side length A, and side length B. So if we want to use the law of sines here, we have to have 3 of those 4 pieces of information, and the same kind of analysis is going to be able to be used when we're talking about the law of cosines later. So a lot of people like to remember all the different cases that exist out there for the different information that can be provided to us for these triangles. Like there might be a side-side-side case, or an angle-side-angle case, or an angle-angle-side case. That is certainly effective to memorize all those cases, but from my experience, it's usually easier just to kind of take the information that is provided, try to plug it into one of these formulas, and it either will work or it will not. So whether we're using the law of sines or the law of cosines, we're always going to need 3 pieces of information, and there's going to be 1 missing piece that we need to be able to find. So for example, if we tried to use the law of sines for our first triangle here, we see that we have an angle that is known, so maybe that is our angle A, but we don't know the side length opposite of that angle, so that could be our missing side length A, but then we'd have to set that equal to sine of a second angle B over its side length B. We know those 2 remaining side lengths, one of those could be our side length B, but we don't know either of those remaining angles, so we do not have enough information to use the law of sines to make progress for this first triangle. We'd have something like sine of 22 degrees over a missing side length of A is going to be equal to sine of maybe angle B over our side length of 50, or we could do sine of angle C over our side length of 20. Doesn't really matter there. Either way, we're going to be stuck because we have 2 unknown pieces of information that we cannot solve for. So the law of sines isn't going to work for our first triangle, so that probably means the law of cosines is going to work, and that is the case because if we think about what the law of cosines requires, for one side of the equation, we need 2 side lengths and the angle between those 2 side lengths. So what do we have in our first triangle? Where we have 2 side lengths, maybe these are side lengths B and C, and then that angle between them is going to be opposite of that remaining side length. That remaining side length would have to be A. The angle opposite of side length A is angle A. So we know little b, little c, and our angle A, and that gives us enough information to have only 1 unknown in our equation, side length little a. So for this first triangle, we would use the law of cosines to get started in solving it. Well, now let's go ahead and move on to our second triangle. This is the one with the 3 known side lengths of 7, 8, and 9. We can try to plug that information into our law of sines equation, but we'd only be able to fill out these denominators and really only use 2 sides of this equation at a time anyways. So no matter how we tried to fill out the law of sines with the information from this triangle, we'd have 2 unknown quantities, neither of which we could solve for. So by elimination, we know the law of sines isn't going to work for that second triangle, so the law of cosines should work, and we can verify that, right? So we know 3 of our side lengths, that's like A, B, and C, and then we could use that to find the angle opposite of one of those side lengths, just depending on which of these values we put on the left-hand side of our equation. So when we know all 3 side lengths of our non-right triangle, the law of the cosines is the way to go in making progress towards solving that triangle and solving for those angles. If you are interested in kind of those different cases that exist out there, we can also describe those as well. So you always basically kind of go around the triangle and just label it using the information that is given. So what I mean by that is as we go around our triangle here and kind of call out the information as it is labeled, we have 50 as a side length, 22 as an angle, and 20 as a side length. So that is a side angle side triangle. or an example of the side angle side case in which we can use the law of cosines to help us solve that triangle. Similarly, the second triangle that we just discussed was a side, and a side. That's our side, side, side case. And again, the law of cosines is going to help us with the side, side, side cases. And so one case that we'll never run into is the angle, angle, angle case where all three angles are known in a triangle, but none of the side lengths are. Because of similar triangles, we can basically make those side lengths anything we wanted to. We just pick one of those side lengths and then it determines the others. So you're not given enough information if all you know is the three angles. But these two remaining triangles do provide us with enough information to solve for them. So let's go ahead and discuss what cases they are and which of our formulas we should use to solve those triangles. So in this third triangle, we are given an angle, a side, or a side, and an angle. I always prefer to write that as the ASS or AS case because it reminds me that this is the ambiguous case of the law of sines. So this is the one case we probably need to kind of keep in the back of our minds and always watch out for, because remember, in the ambiguous case, we may have 0, 1, or 2 possible triangles that can be constructed. And so maybe we would try to use the law of cosines for this third triangle. Let's go ahead and give that a shot and see what would happen if we tried to use the law of cosines for that third triangle. And so if we tried to plug this provided information in for our third triangle into our law of cosines formula, we kind of get this ugly mess. We get 7 squared is equal to 28 squared plus our unknown side length c squared minus 2 times 28 times that unknown side length of c times cosine of 12 degrees. Sure, there technically is only one unknown in this equation, c, that is our side length. And we could solve this using like the quadratic formula, but that'd be pretty gross and require a lot of algebra and probably a lot of rounding error as well. But it does also give us a little bit of insight into the fact that it is a quadratic equation and does have 2 solutions. And in the ambiguous case, we could have 2 possible triangles. So that makes a bit of sense. You will always be able to find 2 values of c using the quadratic formula that would make that equation work, but maybe one of those values of c doesn't make sense. Maybe it doesn't work with the rest of our triangles information, or maybe it's like a negative side length and it's totally bizarre, or something like that. All right, so it looks like we actually could make our law of cosines work for our ambiguous case, but it's a lot of effort. If we compare this to the amount of effort that we'd have to put in using the law of sines, the choice will become obvious, and we should see that we should always handle this case using the law of sines instead of the law of cosines. So with the information provided, we could set up almost 2 sides of our law of sines equation. So if this is our angle A, we could write sine of our angle A, or 12 degrees, over the side length opposite of that angle, or side length A would be 7, is going to be equal to sine of this angle, maybe that's angle B up there, divided by our side length of 28. We could solve this little proportion or equation for sine of B and take sine inverse to find our value for B. And from that, we could see if there's going to be any triangles possible. And we could also then determine if a second triangle is possible and explore that ambiguous case. But it's much quicker finding one of our pieces of missing information in the ambiguous case using the law of sines compared to trying to find a missing piece of information using the law of cosines. Right, and then once we have that angle B, we could find the third angle very quickly using the fact that all the angles have to sum up to 180, and then we could use the law of sines again to find that third side length, or if we really wanted to, we could use the law of cosines. But law of sines is definitely quickest for this ambiguous case, which we can always recognize by kind of going around the triangle with the given information labeled and just reading it off in order as we go clockwise or counterclockwise. If we're going clockwise, we have a side length, and an angle. So that's our side, angle case. And if we're going counterclockwise, we have an angle, a side length, and then another side length, ASS, AS. Again, another way to recognize our ambiguous case. I prefer the acronym of AS to remember the ambiguous case, because if you make the assumption that you are not in the ambiguous case, you may end up making an ass of yourself and get the wrong answer there. All right, so we have one more kind of hypothetical triangle down here we're interested in starting to solve, but we're not actually going to solve it. We're just going to figure out, should we use the law of sines or the law of cosines to get the ball rolling? So in this triangle, we are given 2 angles and a side length. So if we were kind of reading off the triangle, assigning a case to it, it would be like our angle, side case. Or if you do it oppositely, you could do the side angle angle case. It's the exact same thing. And if we tried to use the law of cosines to help us find a missing piece of information about this triangle, we would not be able to make much progress. Notice in this triangle, two of our known pieces of information are angles. But if we're looking at a single equation for our law of cosines, right, we can only use one of these equations at a time. We only have a spot for one angle in our equation. So there's no room or spot to plug in information about that second angle. And then we could plug in one of our side lengths. But either way, there's going to be two missing pieces of information if we attempted to plug stuff in from the angle side case into the law of cosines. So that eliminates the law of cosines pretty much right away. So by elimination, we know it's going to be the law of sines, but we should verify that as well. Well, what information do we have? Two of our angles. So maybe that's angle A and B, and then a side length of 16, which is opposite of one of our angles. Our denominators are always the side lengths opposite of one of our angles. So in this fourth triangle, we could set up something like A, right, our missing side length over here is what I'm calling A, over sine of 30 degrees would be equal to our known side length of 16 over sine of 100 degrees. And from that, we can see we can make some progress and try to solve for the side length of A. The one case we do have to always keep an eye out for is that ambiguous case or the angle side side case. Other than that, just kind of plug and play. Only one of your formulas is really going to work out anyways. And don't be afraid if you chose the wrong formula the first time to scrap your work and try it again with the other formula. So if you tried the law of sines and you saw there's too many unknowns showing up, then try to use the law of cosines and that should get the job done.